You're listening to Impulse to Innovation. The Institution of Mechanical Engineers podcast. I'm your host, Dr. Helen Mees. As a global community of mechanical engineers with over 120,000 members in 140 countries, the Institution of Mechanical Engineers has been at the heart of the engineering profession since 1847. The institution's mission is to improve the world through engineering by sharing the latest news, views and insight into the creative world of technology and the people that make it happen. In this month's episode, we're investigating the growth of 3D construction printing and what benefits it may offer to a world with growing populations and ever-reducing resources. Despite the collapse of construction activity during 2020 as a result of COVID, the industry is already on a path to rebuild its lost revenue in 2021. It's estimated that the value of global construction output will increase from its $11.6 trillion level in 2020 to around $14.8 trillion by 2030. And around 43 million new homes will be required each year globally between now and 2030, with 11 million of these being in India, 7 million in China, 2 million in Nigeria, and 1.5 million in the US. China will, for the foreseeable future, remain the largest construction market globally. However, many developing countries are driving progress in construction as a result of investment in infrastructure and housing projects to sustain economic growth. Construction output in the UK is more than £110 billion per annum and accounts for around 7% of the UK's economic output. Approximately a quarter of construction output is in the public sector and 3/4 in the private sector, with the industry directly providing jobs for approximately 3 million people. That's about 10% of total UK employment. Interestingly, in high-income nations, there's been an increase in demand for infrastructure development using technologically advanced machines and equipment, with the objective of reducing completion times and material handling costs, as well as carbon footprint. This has led to innovations in construction processes, which only a few years ago were considered outside the mainstream. One such technique is that of 3D construction printing, or 3D-CP. 3D-CP covers a wide range of technologies that use 3D printing as a core method to fabricate buildings or construct components, often using industrial robots, gantry systems, and tethered autonomous vehicles. There are a variety of 3D printing methods used, which include extrusion, applying concrete and cement, wax, foam, or even polymers, powder bonding, using polymer bond, reactive bond or sintering techniques, and additive welding. Despite what you might think, the concept of 3D construction actually began to gain momentum in the 1980s, but it wasn't until the mid-90s that construction at scale, using techniques we now recognise as 3D printing, began to emerge as commercially viable processes. Over the ensuing decades, academia and industry have worked together to refine the techniques and learn more about the material properties and the stability of printed structures, and engineers have pushed the boundaries of what was once considered impractical or even impossible. In 2016, the first 3D printed footbridge was constructed in Spain, demonstrating not only the possibilities the technology offered, but also that exact deposition of material, only where it was needed, could significantly reduce the amount of raw materials required. 2017 saw the first 3D printed permanent building constructed, which received all the appropriate building permits, and in 2018 the 3D process was used to create a fountain in Russia. And just a month ago, the IMechE reported the completion of an 18-month project in Italy to 3D print housing structures made entirely from soil adjacent to the building site. The construction of the dome-shaped houses took just over 200 hours. And while there is some way to go before this concept is commercially viable, the team carrying out the work hope that it has demonstrated what can be achieved using natural materials especially in inaccessible locations or poor areas of the world with little effect on the local environment. So, as our global leaders head home after COP26, having discussed issues including infrastructure, the built environment, and our energy use, how will disruptive innovations such as 3DCP become mainstream? And will such potentially sustainable processes be incorporated into their climate change strategies, if at all? I sat down with chartered civil engineer Colin Evison to find out more about 3D construction printing, how it all works, and what innovative applications it might be used for in the future, including the possibility of building homes on Mars. Colin is a fellow of the Institution of Civil Engineers, just across the road from Birdcage Walk, and is also a fellow of the Institution of Engineering and Technology. In his role as Head of Innovation at BAM Nuttall, he has been engaged with 3D concrete printing over the last few years. His interest in 3D printing began when he had small-scale architectural models produced to help him explain the intent of projects such as the Victoria Station and Tottenham Court Road Station upgrades on the Tube. Colin is very passionate about this emerging form of construction, and as he said in our interview, its potential as a building technique is probably only limited by our imagination and the efforts of engineers to solve the challenges that remain. I began by asking Colin to elaborate on the history of 3DCP. Colin, thank you so much for joining us on the podcast today. Now, let's start with a little bit of back history, I suppose, because despite the media curiosity around 3D printing of buildings, this is not something that's new, is it? It's not just suddenly kind of come about. The building and construction industry have been exploring this idea of 3D printing buildings for a long time, haven't they?
Yeah, well, I think we've taken some cues from where we've seen some printing of architectural models. I mean, we've been doing those for 10 years plus, where we've tried to present, a part of a building or part of a structure in a scale down form using a 3D printer. And I guess in parallel with that, people have been thinking, well, why not print life size? Why not print one-to-one scale? So there's been several people around the world, lots of effort in different universities, just trying to work it out, how to make it happen.
You mentioned there about universities. This has really been quite an academic and industrial working together to kind of solve these sorts of problems, hasn't it? There's been a lot of involvement from academia as well.
Yeah, so the work that we've been doing has been focused on Delft University in the Netherlands. So I guess they've got a lot of history of working with concrete, and they've got laboratories to test concrete elements. And I guess they've got the sort of the knowledge and capability to, I guess, maybe go away and try and solve some of the problems that the construction industry throws at them. So I guess, people have thought about, well, you can print documents, that's easy. We can print models. That's a little bit harder, but I mean that's now you can buy one for a few £100s and have it on your desktop. So why not? Can you squirt out concrete and create something that's usable and livable using that technique?
Well, yeah, you talk about that sort of, you make it sound like it's quite easy sort of thing, but we have a 3D printer here at home, and I understand the process that goes into creating those plastic models. But can you tell us a little bit about the equipment that's used for fabricating buildings and structures?
So the robot arm itself is a sort of fairly standard industrial robot. So you see them on videos of car factories and so on. They're fairly. I won't say they're dangerous, but you wouldn't want to get in the way of it. It's a fairly heavy piece of kit. But I guess the clever stuff is the material that it uses. So I mean, printers on a desktop, it can either heat a tub of plastic, or it mixes it with resin or so on. But I guess it looks like toothpaste, to be honest, grey toothpaste that's
Right.
squirted out. But there's some really clever science and chemistry that goes into it to give it the right properties. So you can imagine you print it with ink, it's easy, it comes out wet and it dries in the atmosphere. But of course, when you're trying to print something in 3 dimensions, it has to support its own weight, and I think that's where the clever chemistry comes in.
Yeah, because I just assumed that 3D printing of buildings was just extruding concrete, but it's far from it, isn't it? There's several different kinds of materials that you can use in this process. So can you give our listeners an idea of kind of the sorts of materials that go into this process or that could potentially be used?
So when you think about concrete in its conventional sense, what we essentially do is to pour it into a box, whether it's a wooden box or a metal box, and then we have to wait maybe a day, 2 days until the sort of the chemical reaction takes place. It goes hard, and then you can remove those supports. But the problem with 3D printing is that you need it to go off fairly instantaneously. So the properties is a little bit like non-drip paint, as in
Right.
it's fairly stable until you stir it and agitate it, and then when you leave it alone, it sets. So it's got those kind of thixotropic properties, as well as the sort of the conventional chemical reaction that the cement has with water, that causes it to harden. So you need it to stop moving as soon as it comes out the nozzle, essentially, so it can hold its own weight and then take the next layer as it passes over.
So it's kind of a bit like making a jelly in some respects, isn't it? I suppose you're after
Yeah,
that kind of, or a blancmange, it's kind of that sort of texture.
yeah, it's almost like a huge icing bag, and you sort of
Yeah,
you squeeze this paste out, and it is a paste as opposed to concrete in its conventional form. So concrete normally has gravel in it, say 20 millimeter gravel going down to sand, whereas this has to be more of a paste. So I think the particles are maybe sort of 5, 6 millimeters maximum, so it
right.
can be pumped and extruded out of the nozzle. So it's, I guess it looks like grey toothpaste in its consistency as it comes out of the nozzle. We've tried mixing it with some reinforcing. So the early robots had a spool of stainless steel wire that was extruded at the same time and laid down within the material. But that was quite difficult. You
Yeah.
you couldn't turn a sharp corner in the same way as if it was just the paste when coming out of the icing bag, should we say?
Yes, I guess if you're wanting to get some quite difficult sort of shapes or corners or even curves, but being able to then put reinforcing it must be quite tricky. So, have you been able to find alternatives to that?
Yeah, so the more recent mixes have just been the paste itself, the mortar itself, so it hasn't needed to put that wire in. And then you're sort of freed up from some of the constraints that that wire had. You can do sharper corners, you can come back on itself much more easily. And there's a lot of work that's been done into the speed that this works, because you want it to be a fairly quick process, but also it can't be too quick, otherwise it gets too heavy and it just collapses.
Yeah.
And some really good videos of just like pushing the boundaries of seeing how high the wall can go before it just collapses under its own weight. There's a lot of trial and error, shall we say? There's a lot of piles of this stuff that has to get shoveled up out of the way, I think, before the process is cracked.
Well, I suppose it is a very new process, and you've got to experiment, haven't you, to be able to see what the boundaries are. And I guess the building industry has always done that. You know, from single story buildings right through to the huge skyscrapers we have today. It's all about pushing the boundaries and see how far the materials will go, isn't it? Really?
That's right. So, you look at the sort of the London skyline over history, and you sort of in the 18th century, there's a certain maximum height that you could build to, because you're building out of bricks and mortar. But as those materials have advanced, people are getting more confident, and the sky is literally the limit. So I guess, yeah, it starts small with some small structures, but yeah, as more effort is put into refining the process, then people's imagination really is only the limit of what can be built.
Yeah, I suppose it's a great opportunity to try new things. It's a bit kind of Lego build in some respects, isn't it? It's that opportunity to put things in different places and see what happens. I was reading recently that because you've talked there quite a lot about concrete, I was reading recently that there'd been some work done to look at using clay as the medium for laying down these buildings, and potentially that the uses in developing countries, and particularly I think this has been trialed in Africa. Do you think that there's an opportunity to look at other kinds of materials like that to be able to use them perhaps in other parts of the world?
Yes, I mean certainly concrete is definitely got a bad reputation these days, just because the sheer amount of energy that is consumed into making it. So the idea really is that it's not a long-term sustainable solution that it is. However, the structures are more efficient in that you only put material where it's needed. I mean, when you think about conventional structures, you just have a rectangular box and you fill it full of concrete. So it's not necessarily all the material is needed. It just
Yeah.
fills that void. So you can target the materials. That's one advantage of the process. But also, yes, can you use other materials that act in a similar way? Maybe you can reduce some of the cement and look for some alternatives that react and they can harden, maybe with heat, maybe with sunlight,
Yeah.
to make it more accessible to different countries that it might have access to the materials, or the cost of the materials is prohibitive because there's not much of it that's produced at the moment.
Yeah, well, that leads me nicely on actually to a question about sustainability, really. And those that are working in this particular area are very keen to look at the advantages that 3D printing buildings might have. There's been talk of the process being twice as fast as conventional construction and with 10 times less waste. Do you think that these are realistic claims, and could 3D printing be one solution that we might have towards our sustainability or our climate crisis issues that we're facing?
Yeah, so the question that usually comes up is what does it cost? And I guess what they're asking for is the monetary value how much does it cost to print one of those as opposed to build one of those out of conventional means? But
Yeah,
it could be the human cost. So actually, maybe if it's something that's produced by a machine, there's less chance of either splashing concrete in your eye or dropping a brick on your foot. So there's the human element. There's the carbon element, so if you're using material more wisely, um, and also if you're looking at, maybe, we talk about the skills shortage in engineering and the construction
yeah.
industry. If you can automate a process, then maybe these things are more accessible to people where the skills aren't available. So yes, it can be looked at in lots of different ways in terms of sustainability, and certainly the need to reduce the carbon impact of the construction industry is a huge driver into how this process develops.
Yeah, I think certainly for again for developing countries or low income countries, I think that's going to be a real benefit, isn't it? To be able to reduce the amount of materials that they use and reduce that cost, so that it gives the opportunity to more people get greater access to these kind of buildings in the future.
And one of the things that has been explored is, instead of having a permanent factory, so the factory that we were involved in was in Eindhoven in the Netherlands. So it's not necessarily convenient if you want to produce something for the UK. It still has to be shipped across the North Sea. But we have experimented with what we call the flying factory. So we've containerized it, and it's been to Las Vegas previously
Wow.
at the Autodesk conference, where it was set up doing a bit of a demonstration. We also set it up at Heathrow Airport. So in the logistics centre there at Colnbrook, we set up, if you like, a temporary factory that produces printed concrete elements. So again, you're adding another layer of complexity because it's quite sensitive in how it's set up and how it's leveled. But I guess it starts to produce the idea of, well, actually, you can take it to the construction site as opposed to producing things in a factory which have to be transported. So yes, you can print the house or you can print the bridge actually where it's going to be needed.
Yeah, yeah, and again, reducing the carbon footprint of just one item being transported instead of several, which I guess for a very large construction, a very large building or a bridge, is tons and tons of material that are having to be transported to and from site.
Yeah, and a lot of it's you have to challenge convention. So people are used to putting concrete in a box and taking the box away, and you're left with a structure. So even the finish is a bit of a challenge because people are normally say, well, the concrete has got a smooth texture because it's formed into something that's a smooth piece of formwork, whereas this has got a textured surface. So you have to rethink about what might be acceptable. So that's you've
Yeah,
got to challenge people's conceptions about what you can do with material. People like to live in a brick house, even though that laying bricks is a really sort of outdated form of construction. So maybe you need to show people that well, maybe you'd like to live in a house that's produced using this technique. Maybe you want to have something that looks a little bit different.
I think people are becoming much more aware, aren't they, now of the need. Going back to my question on sustainability, that the need for different methods of construction and building. You know, I live in an old 1950s building. You know, it's got a concrete base for a floor and it's got red bricks, and I think challenging people's perceptions of what a house or you know, or a building might look like, I think is a really exciting opportunity. I mean, certainly from an engineer's point of view. I don't know about the rest of
Yeah, I
society.
mean, I guess we're programmed to live in, square boxes because it's easier to build something that's square or a cube or rectangular because the modules that we build it out, so say the bricks, are just, a small rectangle. So, that's what the end solution looks like. But if you're printing something in 3 dimensions, then if you want a curved corner to your house, then you can have a curved corner to your house. It might make some of the furniture and having to cut a carpet to a radius a bit of a challenge, but you can have a more organic shape, shall we say, a more maybe something that
Yeah.
fits into the landscape in terms of its shape.
Yeah, absolutely. Now, I mean, we've talked there about some of the exciting opportunities that 3D printing of buildings will have. But what do you think are the downsides? What do you think the disadvantages come in 3D printing construction?
Well, one of the challenges is, I guess, gravity. Because when you look at some of the 3D printed models, some of them are printed in a liquid reservoir, or they're printed in a bed of powder, and that support material provides support to the model whilst it's being constructed. But of course, when you're printing a large item in the outdoors, it's very difficult to have that temporary support mechanism there. So if you're looking to some kind of overhang, you can only overhang the last layer at a certain amount. Otherwise, it just topples and collapses. So I guess that's maybe a function of the physics of the material that's used today. Is there's no reason to think about, you could print in free space as opposed to being a layer on top of the previous material that you've extruded. So maybe that's just a constraint that exists where the technology is today. It's still relatively young. It's only been, a matter of years or a decade or so. So it's still early days, really, in people's the amount of effort that's been applied to it to see where it could go.
Yeah, I remember going to a 3D printing show, you know, just the sort of the desktop machine type things, and seeing somebody with a pen that could you could draw with the 3D printing material, and it came out in a way that allowed you to build structures. You know, I'm guessing that the technology for buildings has got to come on a long, long way before they're going to be in a position to be able to deal with that kind of behavior from the material and understand the, as you rightly say, the physics of creating these constructions.
Yeah, and maybe we do reach the limit of what a cement-based material can do when we look at composites, maybe, or maybe you can use some form of recycled plastic. So you can maybe harvest all the plastic that's dumped, and maybe you can come up with a process where you can have that free form 3D printing, but in a larger scale, and actually you manage to eat up all the single-use plastic that we seem to be burying ourselves in. So that sounds like it can add up.
I love that idea. I absolutely love that idea, Colin. I think the idea of pulling all of that plastic out of the ocean and creating something that we can live or work in or just enjoy by reusing it that way. I think that sounds like a fantastic idea. I think there's going to be a lot of engineers who would really like that challenge.
Exactly. It just needs someone to go, why can't we do this? And you'll just get someone who's got the dogged determination going, I'll tell you what, I'm going to make it work. It might not be easy. It might not be next week, but yeah, I'm going to put my mind to it and damn it, I'm going to show people that it's possible.
Absolutely. Well, that kind of nicely leads on to my next question because, again, I've been looking at some of the things that are coming out of NASA and some of the potential for deep space missions, and they've been considering using 3D printing as a means of construction, either on the moon for a moon base or on Mars for these long term deep space missions. Do you think that that's a realistic thing? Are they going to pack, like you've been talking about your shipping container with your robot in, are they going to pack something like that into a spaceship and take it off to Mars? Or does that seem completely out of any realms of reality. And I suppose a follow-up question to that would be, what do you see as the next terrestrial innovation that 3D printing, 3D construction might have?
Well, I guess the challenge, if you're going to ship a building to another planet, is that there's just so much of it. So the idea is that if you can use the rock and the material that's already there, then you just need to ship something that can process it. So I guess they're onto something, and I guess the kind of budgets that NASA might throw to the problem, the chances are that they end up coming up with a solution. In terms of where it's going to go next, I think the more that we, I guess, get comfortable with seeing some of these printed objects, the more people will start to think of what might be possible. I mean, we've printed all sorts of things. We've printed the initials of our company, BAM, just to have as a sign when you enter into the office. We've printed
Yeah.
picnic tables and seats, and I think last year we printed a 3D printed concrete Christmas tree. So again, it's a bit of a novelty throwaway item, but it just shows people that, oh, you can do a different shape, you can do a different object, and it just, I guess, the more that you put the people in front of the process and front of the finished product, it just starts to spark the imagination of, well, why can't we use it to do one of these, or can I use it to solve this problem?
Yeah, I quite like the idea of having my own 3D printer in the garden, just to knock up things that I might want. I mean, and I make a joke from that, but actually, it wasn't that long ago where we would have never considered having a plastic 3D printer on a desktop in our house. It was the realms of industry and huge big machines. Now they're commonplace, and people can even build their own. So I'm guessing that maybe at some point in the future, hiring a 3D printer to come and do some building work at your house, or having one that you can make furniture for the garden, or even your shed, would be something that might be commonplace, mightn't it?
Yeah, that's right. I mean, like you say, it's accelerated very quickly. Previously, you'd have to pay tens of thousands of pounds for one of these, office grade architectural 3D printers. And like you say, now it's a school project, where you can build it in a matter of hours and start churning out objects. So yeah, maybe a few years time you can hire one from B&Q. You can pick a QR code of, do you want a chair or a table, and you set it up as your weekend project. I'm going to print myself a picnic bench for the garden.
Excellent. That sounds like a great idea. I'm looking forward to that. What's the next big project you're working on? Because you've done a lot of construction in bridges, haven't you, Colin?
Yeah, so we've built a few bridges, fairly small bridges, sort of single span bridges, say 9, 10 meters long. And they've been printed out of sections of 3D concrete printed, and then they're tied together with steel bars. So that, they're quite slender structures. They're a lot better than the first ones we did. The first ones were a bit heavy and chunky, so people are getting more used to. Well, the design of the structure is a challenge because there's no design book that tells you how to do this
Yeah,
stuff. You have to design it from first principles. And the first bridge that we printed, it was literally loaded with huge containers full of water to replicate what it would be to have loads of people standing on it.
yeah,
And it was tested and it was measured and it was said, yeah, it was fine because, part of the challenge is there's no standard that says how do you design a 3D printed house. So you really have to go back to your engineering basics. What am I trying to achieve? What loads does it has to stand up against? And what does it need to look at? So it's, yeah, you're asking the engineer to go back to the basics rather than follow. "Oh, well, here's one I did earlier." You're starting from scratch, which is part of the excitement of engineering, I guess.
yes, certainly pushing the boundaries. Thank you so much, Colin, for taking the time to talk to me today. It's been fascinating. I'm quite excited to see how this whole process develops, particularly along the lines of sustainability, which is something that's very close to my heart. And I think there's some great opportunities there for wider society to really embrace this new technology. So thanks very much for talking to me today.
Thanks very much, Helen, and thanks for inviting me.
That's all for this month. In next month's show, we will be getting the lowdown from COP26 as the IMechE young members review the international conference, its highs and lows, what impact it will have on the international engineering community, and whether it will truly be a line in the sand for our global climate crisis. Also, in a special episode during November, we will be talking with IMechE CEO Dr. Alice Bunn and members of the Trustee Board and Real Estate Strategy Board to discuss securing the future of our HQ. Is our 122-year-old building fit for purpose? How do we create an inclusive and accessible venue for everyone? And why should our 120,000 members care about this iconic London landmark? You've been listening to Impulse to Innovation, the Institution of Mechanical Engineers podcast. Thanks for listening. We'd love to hear from you, so if you'd like to share any news or any feedback with us, then please email us podcast@imeche.org. All the information on this episode can be found in the episode notes.